We're going to talk about day 3, triangles. I may bring that up every once in a while because it's very sad what happened. But we're going to be talking about these things called special/reference triangles. And I have no idea why my computer is doing that. Let's see, am I going to be able to draw now? Okay. I should end up here. Mr. Key is back to help you out. Okay, we're going to start with an isosceles right triangle. You know it's an isosceles right triangle when I tell you it's a right triangle and these angles are 45 degrees. Both of them are 45 degrees. So to make our life easy, what we're going to do is we're going to say, okay, this is 2. And I want you to find these two sides. Now, I know these two sides are the same, but I'm not exactly sure what they are. So let's see here. Let's say, oh, we have a right triangle. And since they're the same, I can call them both x. So I can use the Pythagorean theorem, x squared plus x squared equals 2 squared. Or 2x squared, because when you add these two up, you get 2x squared is equal to 4. Or when you divide both sides by 2, you get x squared is equal to 2. And then when you come up and you grab a different color pen and you take the square root of both sides, you get that x is equal to the square root of 2. So this is equal to the square root of 2. And this is equal to the square root of 2. So let's go through the original 3 trig functions. Let's assume we're going to use this angle right here. So I'm just going to erase this one up here. We're going to use this angle right here, and we're going to label our diagram O, A, and H. O, H, and A. And if you remember, we've got some old horse caught another horse taking oats away. So sum is opposite over hypotenuse. So what we're going to do is we're going to write sine of 45 degrees is opposite, which is the square root of 2, over the hypotenuse, which is 2. Cosine of 45 degrees, which is adjacent over hypotenuse, and adjacent is 45 degrees, or excuse me, it's square root of 2, and the hypotenuse is 2. And then tangent of 45 degrees is equal to the ratio of sine over cosine, or opposite over adjacent, which is the square root of 2 over the square root of 2, which is just equal to 1. So those are your 3 main trig functions. Now what we're going to do is we're going to use their reciprocal functions. So cosecant, which is the reciprocal of 45 degrees, is of sine, is the reciprocal of that, which is 2 over the square root of 2. Well, you can't leave it like that. So what we're going to do is rationalize it as multiplying by radical 2 over radical 2, and I get 2 square roots of 2 over 2, because square root of 2 times square root of 2 is 2, and these cancel, so this is just equal to the square root of 2. Well then secant, which starts out the same thing, secant is still the reciprocal of that, which is 2 over radical 2, so that also must equal the square root of 2. And cotangent is pretty easy. It's the reciprocal of 1. Well, the reciprocal of 1, guess what, is just 1. So those are your 6 trig functions for 45 degrees. Those are going to be committed to memory eventually. Mostly these will be. All right, kids, now we're going to work on an equilateral triangle. All right, we know an equilateral triangle has 3 congruent sides. And we're going to make each side 2 again. But in order to do that, then I know that this and this are congruent because an altitude of an equilateral triangle bisects the bottom side. So these are both 1. And then the other thing I know in an equilateral triangle is that these angles are all 60 degrees. Well, if they're all 60 degrees, then that makes this angle 30 degrees. And there is your famous 30, 60, 90 right triangle. 30, 60, 90 right triangle. Up here I should have written that this was the 45, 45, 90 right triangle. Those are the 3 special triangles that we're going to deal with today. All right, so I want to find this missing side. I'll call it x. Well, I know that x squared plus 1 squared is equal to 2 squared. Or x squared is equal to 3, or x is equal to the square root of 3. Sorry about that. Waiting for a phone call from my son. I want to talk to him because he's away at college, and I want to talk to him. Never stop talking to your parents or friends or anybody that you trust in your life. Never. All right, so we're going to look at just this triangle on the right. We're going to use this. I guess we're going to use this angle right here. Well, let's use the 30-degree angle. Let's use the 30-degree angle. We'll start with that one. So let me clear this out. You're going to have to write smaller. I want to be able to you to be able to see, or you're going to have to use the margins or whatever. So I want to start with the sine of 30 degrees. Well, before I do that, I should probably label it. This one, I'm talking about this angle up here. I'm going to fill it in. I'm talking about this nice light blue angle. Then this is opposite. This is hypotenuse. And this is adjacent. And we already said that this was the square root of 3. So sine is opposite over hypotenuse, or 1/2. Cosine of 30 degrees is the square root of 3 over 2, which is the adjacent over the hypotenuse. And tangent of 30 degrees is opposite over hypotenuse, which is 1 over radical 3. Multiply by radical 3 over radical 3, and I get tangent of 30 is equal to radical 3 over 3. All right, those are the first 3. Now let's do the reciprocal functions. Cosecant 30 is just the reciprocal of this. Well, that must be equal to 2. Secant is the reciprocal of this. Well, this one's not as easy. It's equal to 2 over radical 3. We need to multiply by radical 3 over radical 3, and you get 2 radical 3 over 3. And finally, cotangent. Now, cotangent 30 is the reciprocal of this. But I'm going to take the reciprocal of what it originally was, which this right here. Because when I take the reciprocal of that, I just get the square root of 3. I mean, this became this. But if I took the reciprocal of this, then I would have to rationalize it, and I'd end up with just this answer anyway. So those are the 6 for 30 degrees. Now you're going to see something interesting for 60 degrees. Let's do cosine. Oops, excuse me. Let's start with sine. All right. Try to keep this in as much as possible. But we're going to use this angle now. We're going to use this angle down here now, which is a 60-degree angle. All right, so the sine of 60 degrees is equal to opposite over hypotenuse. Oh, wait, we got to relabel then, don't we? This is no longer A, and this is no longer O. This is now O, and this is now A, because we're talking about this angle right here. And this would be opposite. So opposite would be square root of 3 over 2. And then the cosine, the cosine of 60 degrees would equal adjacent, which is 1 over 2, 1/2. So let me write that nice and neat. The cosine of 60 degrees is 1/2. And then the tangent of 60 degrees is equal to opposite over adjacent, which is just the square root of 3 over 1, which is just the square root of 3 over 1. So did you notice that these were just opposites? And you notice that these angles add up to 90 degrees? We're going to come back to that eventually at some point. All right, let's go. Cosecant of 30 degrees is equal to the reciprocal of secant. Well, that would be 2 over radical 3. Well, we already did that work. We did it right here. We know that that turns out to be 2 radical 3 over 3. And secant, this is of 60 degrees. Sorry about that, kids. 60 degrees. Secant of 60 degrees is the reciprocal of this, which is just 2. And cotangent theta is just the reciprocal of this, which is really just this, square root of 3 over 3. And we should say of 60 degrees. I don't know why I didn't write 60. I'm really having a hard time with that. I'm a little unfocused today, if you can't tell. And I'm not as cheery as I am normally, so I apologize. So, what are we going to do? 30, 60, 90, and 45, 45, 40. 45, 45, 90. Let me try to get my brain back. Thanks, Brugers. Appreciate it. Any 30, 60, 90, or 45, 45, 90 right triangle is just a dilation of these two triangles above. So if you take any 30, 60, 90 or 45, 45, 90 right triangle, it has to be some kind of dilation of one of these two triangles from above. Therefore, the triangles are similar. And because they are similar, the angles are congruent. Well, that makes sense. If you have a 30, 60, 90 right triangle and you just blow it up, it's still a 30, 60, 90 right triangle. The angles can't get any bigger. They're still 30, 60, 90 or 45, 45, 90. But these are the special triangles that we're going to be working with. And the side lengths are proportional. So, which means we can set up one ratio equal to another and find their size. All right, so let's get started on some work. So find the exact value. So first of all, I should have probably drawn a better 30, 60, 90 right triangle. But our sides are, if we started with the 1 here and the square root of 3 here, then the other side missing was a 1. All right, so we're going to dilate this shape. I got to get this smaller so you can actually see what's going on here. Minus, there we go. So this is 30, 60. Now I know, just as a little heads up and an aside, I know that this square root of 3 has to be opposite the 60 degree angle because the square root of 3 is equal to 1.732 ... which is much bigger than 1. And so the 1 has to be opposite the 30 degree angle. Eventually, I'm going to show you what I'm going to ask you to do for this, or to think about for this problem, for these kinds of problems. But let's take a look. All we did was dilate this shape. We made it a lot bigger. So this is now my 60 degree angle and 30 degree angle. So if I want to find x, then I know the sides are proportional or in the same ratio. Or in other words, the square root of 3 over 2 is equal to, so let's say I put this side over this side, is equal to x over 8. I don't know why I just did the square root. Is equal to x over 8. And now I can just cross multiply, or 2x is equal to 8 square roots of 3, divide by 2, x equals 4 square roots of 3. If I wanted to find y, then I would use that same ratio. Well, I'd use this ratio. 1 is to 2 as y is to 8. Well, that should be pretty easy. That's just a half, so y has to equal 4 to make a half on that side. One of the things I'm going to ask you to do is I'm going to ask you to use this triangle. I want to use this triangle. 1. This is a half, and this is the square root of 3 over 2. It's the same exact triangle as we have up here. Actually, what we're going to do is we're going to realize that this triangle down here is really just this triangle up here, because this triangle up here is much easier to use. So you're going to see this triangle when you do your spiral and you start working on your spiral. You'll see this triangle come up over and over and over again. But this triangle is just a dilation of this triangle. Now they're similar, 30, but if I multiply all these sides by 2, because that makes my life easier, I get 2, 1, and just the square root of 3. So it's really this triangle here that we're going to be using the most. Hypotenuse 2 and sides square root of 3 and 1. But when you draw it, I want you to make sure you understand how you're drawing it. I want you to draw it properly, with this being the long side, this being the short side, and then up. And then we do 2, 1, and then the square root of 3. Because square root of 3 is almost twice as big as 1. So, again, this should be 2. I know it doesn't look good. Let me redraw that too. All right. You'll see where this triangle comes into play when you start working on your spiral. All right. Let's say we want to find the side length here, or this side length. Doesn't matter, they're going to be the same. So let's do, let's see, square root of 2 over 2 is equal to x over 5. Cross multiply, I get 5 square roots of 2 is equal to 2x, divide by 2. So I get these are equal to, x is equal to 5 over 2, or 5 square roots of 2 over 2. That's pretty much all there is to it, kids. And that, by the way, I forgot to tell you, this was a 45, 45, 90. Oh, I didn't need to tell you that because I told you the side lengths were the same. So it has to be a 45, 45, 90 right triangle. This next chart's going to help you on your spiral, as well as the video I create for you. And I did say memorize it for tomorrow's class. Clearly, I should have taken that out because we're not doing it. But you do need to memorize this stuff. Let's see how we're going to do this. Draw. So the first thing I want to do over this 45, 45, 90 right triangle is draw my triangle in. 2, square root of 2, square root of 2. 45. So let's use this angle, and let's label it hypotenuse, opposite, and adjacent. So sine opposite over hypotenuse, square root of 2 over 2. Cosine, square root of 2 over 2. Tangent, square root of 2 over the square root of 2, which is just 1. Well, that makes this one just 1. Now, I want to take the reciprocal of this, which is 2 over the square root of 2. And we've already done this math. We're going to multiply by the square root of 2 over the square root of 2. And you get 2 square roots of 2 all over 2, and these cancel. So this is just equal to the square root of 2. And this is just equal to the square root of 2. Now let's look at the 30, 60, 90 right triangle. Long side, short side, hypotenuse. We're going to make the hypotenuse 2. In both cases, we're going to make the hypotenuse 2. Short side is half, and this is the square root of 3. You have to remember that. We're going to use this angle right now because we're talking about 30. So we're going to use the 30-degree angle. We're going to label it opposite, hypotenuse, and adjacent. So sine is opposite over hypotenuse, which is 1/2. Well, let me just flip that around. That's 2. This is the square root of 3 over 2. And we already did that. If we take the reciprocal of that, it's 2 over the square root of 3. You multiply by radical 3 over radical 3. And you get 2 radical 3 over 3. So 2 radical 3 over 3. Tangent is opposite over adjacent, which is 1 over radical 3. And if I rationalize that, I get radical 3 over 3. So radical 3 over 3. And that makes this one the reciprocal of this, which is just radical 3. And we've already done this on the page before. Now, if we're going to deal with cosine, what I have to do is I have to adjust these. I can't use these anymore. We're going to use this angle up here. And now this is opposite and this is adjacent. And we'll grab a new color. How about green? Sine would be square root of 3 over 2, opposite over hypotenuse. And then we'll just kind of use this one. And right? This one is going to be 2 radical 3 over 3. Cosine is adjacent over hypotenuse, which is 1/2. That would make this 2. Tangent is opposite over adjacent, which would be the square root of 3 over 1, which is just the square root of 3. And then this one will be the square root of 3 over 3. Start committing this stuff to memory. You're going to have to know it eventually. So we're going to use this information now to solve these problems. So I've drawn my 45, 45, 90. I want to put my important information in. 2's are the hypotenuses. Square root of 2, square root of 2. This one, the opposite is 1, and the adjacent side is the square root of 3. So, sine of 45, we know that's the square root of 2 over 2. The tangent of 45, if you look above, is just 1. So this is just equal to the square root of 2 over 2. Done. Secant of 45. Secant. Now, what I'm going to do is I'm going to say, look above, and I'm going to say, okay, the cosine of 45 degrees is the square root of 2 over 2. So the secant is 2 over radical 2. Now, I could use that thing up there. I'm not going to just do it just yet. I will rationalize at the end. Cotangent of 45 degrees, well, that's going back over here. That's 1. Oh, that's just 1. So this is 2 over radical 2. And, of course, if you rationalize it, you just get radical 2. All right. Keep moving. 4 times the cosine of 45 degrees. If I look above, the cosine of 45 degrees is the square root of 2 over 2 minus 2 times the sine of 45 degrees, which is also the square root of 2 over 2. Let's see. This 2 goes into here twice, so I get 2 square roots of 2. These cancel. Minus the square root of 2. So this is just equal to the square root of 2. And this is finding the exact value. You're not going to use your calculator. See this word exact? I'm going to let you know and we'll talk to you about it tomorrow. But that just means exact value means you're not using your calculator. Sine of 45 degrees, square root of 2 over 2. Cosine of 30, we're going to come back over here. Cosine of 30 is adjacent over hypotenuse. This is the 30-degree angle. This is adjacent. So square root of 3 over 2. And something you all seem to struggle with. When you multiply radicals, you multiply the numerators. And since these are both in radicals, I can multiply them together. I get the square root of 6 over 4. This can't be reduced because the 6 is in a radical and the 4 is not. All right. Now, this is new notation. So I want to tell you what this is equal to. This is red tan squared of 30 degrees. Well, this is how you're going to see it. This is how I want you to rewrite it. It's really tangent of 30 degrees squared times the sine of 45 degrees squared. The square really goes on the outside, but in order to be lazy and not have to worry about it, we put this squared right here, and that way I don't have to rewrite it like this. So the tangent of 30, let's go back up here. Tangent of 30 is, that's opposite over adjacent. That's 1 over the square root of 3. So I'm just going to use that. 1 over the square root of 3, but we're going to square it, times the sine of 45, which I've now committed to memory, square root of 2 over 2, squared. Well, this is just 1 over 3. 1 squared is 1, square root of 3 squared is 3, times square root of 2 squared is 2, all over 2 squared, which is 4. So my final answer here, not my final answer, is 2 over 12, which is equal to 1/6. There's my answer. Tangent of 45, if you look above, that's the square root of 2 over the square root of 2, which is just 1, minus the sine of 60. Let me go look at the sine of 60. If we're talking about this angle, this is opposite, and this is hypotenuse. So 1 minus the square root of 3 over 2. Oh, crap. We got some work to do. In order to add these, I have to have a common denominator. My common denominator would be 2. So this would be 2 over 2 minus the square root of 3 over 2. So my final answer would be 2 minus the square root of 3 all over 2. And yes, that is an acceptable answer. And it's exactly what I'm going to be expecting. All right, kids. That's it for special right triangles. Hopefully you enjoyed those notes, and listen to me carefully. Take care of each other. Find friends. This light has not been on this whole time. I hope that doesn't ruin anything. That's kind of silly. Take care of yourself, take care of your friends, and take care of each other. All right? That's it. Peace out.